Hello viewers, this heritage tutorial, and today we'll be talking about motion. We'll be treating the laws of motions, Newton's law of motion. Talking about the Newton's law of motion, we're talking about the first law, we're talking about the second law. Now, first law says a body will be in a state of rest or a continuous, a uniform motion if no external force is acting on it. That means F is equal to what? MA. A body continue to remain in a stationary position if no external force is acting on it, or a body will continue to move in a uniform motion if no body is acting on it. So that's the first law of motion. Then the second law of motion is that the force applied to a body is directly proportional to the what? Acceleration, where the mass remain constant. So what I'm saying is, we have F equals to ma from the first one. So F is directly proportional to the what? Acceleration. That means F, it says what? Mass remain what? Constant. F equals to what? Ma. And you can further say F equals to what? You can further say F equals to what? Mv over what? T. So most times this second law, they mostly use it for if you want to get the momentum, if you want to get anything, this second law is mostly applicable. So we'll be dwelling on that for today. So, and we know the first equation of motion. Which says V equals to what? U plus what? AT. Second equation which says S equals to what? UT plus what? Half AT square. The third one, V square equals to U square plus 2AS. These are the three basic equation of what? Motion. Although there are others like S equals to U plus V over 2T. There are others. But we'll be dealing basically with these three, this first, second, third. But for today, we'll be talking about the first one and the second one. The first one and the second one. Now, this V you are seeing here is velocity. This U you are seeing here is velocity. So what differentiates them is that this V is what? Is the final what? Velocity. This U is the what? Initial velocity. The A is the what? Acceleration. And the T is the what? Time. The T is the what? Time. Now, for example, a car is in a stationary form. Now, the car ignites the engine and starts moving. Now, there is an initial velocity for the car. I said it's in a what? Stationary form. That means the initial velocity at that moment is what? Is 0. The other cases where the car is moving, the initial velocity is the first velocity of the what? Of the body. From the question, you can deduce that from the question. Is either the question is telling me that the body is in stationary or the body is already in motion. So why the final velocity is the final velocity before the body comes to rest. So we have U, we have V, we have acceleration, and we have time. So questions might come in different way. They might ask you calculate the final velocity whereby you are given the initial velocity to be 0 You are given your acceleration to be what? To be 5 meters per second square. You are given your time to be 25 seconds. So you just know you have to introduce this to the formula where your u is 0, your a is 5, and your t is 25. So that is just 5 times what? 25. Then we have other cases where the acceleration, where this a is not accelerating and is decelerating. Then the a will be what? Negative. When your body, when your car is decelerating, you have the negative what? Acceleration. So for example, you are given your final velocity to be what? To be 25 meters per second. Your initial velocity to be what? Is 0. And they said, okay, your initial velocity to be 0, your acceleration to be -5. Now, once you are given -5%, you should know is what? Deceleration. Or they can simply call it deceleration, but most times they might tell you it accelerates with what? This. Now, it decelerates with this, I mean. Then your time equals to what? 2 seconds. So now, I've even listed all the parameters there. So I'm just trying to show you that this plus is not a constant. It might be plus or what? Minus. It might be plus or minus depending on the direction. Is it moving upward or downward? If it is moving upward, that is what is against the what? Gravity. If it is moving downward, is what? In support of the what? Gravity. Now, then the same thing applicable to this second one. This s is the what? Distance. Is the distance, or you can call it height. It's just the measure of the length, the distance, the measure of the distance. Why this one is also what? Plus or minus. Since you are seeing acceleration, it can accelerate or what? Decelerate. So we have the initial velocity, we have the time, we have the acceleration, and we have the time. So I believe those are the basis for this equation of motion. Those are the basis for equation of motion. You can see from this formula, you know, and your acceleration is what? V minus u. Sorry for this. The acceleration is what? V minus u over t. So I'm just trying to tell you that this formula is derived from your acceleration. This common acceleration, you know, to be what? A equals to change in velocity over time. So the formula is derived from this. Your change in velocity will be what? The final velocity minus the what? Initial velocity over what? The time. Now, when you do your subject on formula, you cross multiply, you have AT, then your u will go to the other side. So that's how they come up with this formula. It is derived from this formula. So that's to tell you that you must be familiar with all these basic formula. All these v equals to distance over time, a equals to v over t. You must be very familiar with them in this course. Okay, so that will be all for today. In our next class, I will solve more example on this, and I will explain on the third law of motion, the third equation of motion. Thank you so much.